Here is the Milky Way. This is a photograph I took on a recent out-of-the-body experience. 100,000 light years across, 100 billion stars. So a typical galaxy has 100 billion stars. Actually, this is not the Milky Way. The Milky Way is not quite so pretty as this galaxy. If this were the Milky Way, this is where we are. So we're not in Chicago, we're out here in Charlottesville. 25,000 light years from the center. This, of course, is what the Milky Way looks like when you try to piece together the sky. So just figuring out what our galaxy look like is complicated because we're in it. That's another story. Here's Andromeda. It's the nearest galaxy. It's a little closer than the typical separation of galaxies. It's 2 million light years away. So that means that on Andromeda, they're looking at Earth and they're seeing, do you remember Lucy walking through the ashes in Africa? So 2 million years is how long it takes light traveling really fast to get there. And it's fun. We think of Andromeda as our twin, and I think it's a really healthy thing that we think of it as our twin. We think of it as being about the same size. It's actually twice as big as our galaxy, but that shows we have a good healthy ego. And galaxies come in all sizes and shapes. This again is fun. This is Hubble's tuning fork, and he called the elliptical galaxies the early type galaxies, and the spirals the late type galaxies, because just classifying them. We now know that in terms of evolution, it goes in the other direction. The nearest cluster. So galaxies like to cluster, and the nearest cluster is Virgo, and it's only 50 million light years away. And so it's a little. These galaxies are all in Virgo. And breaking news: we got elected to membership in Virgo. So we're going to be a member of Virgo. We've been invited to join. Due to the nature of gravity, we cannot turn down that invitation. We will, a few billion years from now, be a member of Virgo. Here is the Coma cluster, which I'll come back to next time. It's farther away, so you can see it's actually more spectacular on the sky. You see fewer stars, about 2,000 galaxies in it, the Coma cluster of galaxies. This is the most distant cluster of galaxies. It's about 10 billion light years away. This is fun. So there are all kinds of interesting objects in the universe, and it's easy to get tripped up. Everybody's heard of a quasar? Okay. They were originally called quasi-stellar objects because they look like stars, but it turns out they're about 100 billion times brighter than stars. Which one is the star and which one's the quasar? So they look exactly like, when they were discovered, they look exactly like stars. I showed you a quasar. This one is, and you could have used logic to figure this out, it's at the center of the picture, so this is amazing. But they look just like stars. And one of the pressing questions when quasars were discovered by Alan Sandage, the second most famous astronomer of the last century, was what are they? Extremely bright, extremely distant. Are they a new class of things? And we answer that question with the Hubble Space Telescope, and the answer is quasars are galaxies and they're terrible twos. So it turns out when galaxies were young, the black holes at their centers were eating up stars and putting out a lot of light. And so the Hubble took images of quasars. There's the quasar, and if you look very carefully, you can see that it's sitting in a galaxy in each one of these. And so that question was answered. And of course, there are black holes, everywhere. What does this say? A black hole is born every 10 seconds in the observable universe. Okay, and here's the large-scale structure of the universe. This is what the universe looks on the largest scales. So let me orient you. This is a survey that was done by the project I was telling you about earlier, the Sloan Digital Sky Survey. We're at the center, so and Harvard wasn't even involved in it. So we're at the center, and then this is distance away from us. This is one of the angles on the sky. I can't show both angles on the sky. So I'm showing a thin wedge about 10 degrees, and that suffices to show what the universe looks like. Now you're going to ask about this. So there's big empty spaces in the universe. You know, this is when we're looking through the disk of our own galaxy and we can't see very well. And so this is where we can see well. And so what you see is, and each one of these dots, and the dots blur together because there's 100,000 or so of them, is a galaxy. So I didn't say this, but I implied it. The basic building block of the universe today is a galaxy. And so the structure of the universe, when we talk about the structure of the universe, it's defined by the distribution of galaxies. And so what do we see? So number one, we see there are big regions where there are no galaxies. Those are called the voids. And they're about 150 million light years across.